we got audio apparently. Okay, there we go. Yeah, and I got an email. All right, so if you're subscribed, and we are live. All right, sorry for the delay on that. But let's get started. We'll run through this really quickly. We got some code to show you, but we're going to start off because this is an intro to everything. Showed a little bit of yesterday, but we'll go over some of those other things. So these notes obviously will be in the repository, links to all the things we discussed yesterday or last class. Getting started developing iOS apps, the Swift book, Swift 5, and then some of the other links. Apple Developer Portal, in case you still haven't downloaded Xcode, go ahead and do that through this link. I will try to also put some of these links in the video description so you don't have to go and try to find it through the notes. I'll try to post this as many places as I can for you. Make it easy. I do want to mention that if you're able to, some of the libraries have a free account for lynda.com, which is now LinkedIn Learning. I guess everything's owned by Microsoft these days, but LinkedIn bought Lynda, and Lynda has tutorials on everything, including Android development, iOS development, game development, Unity, Unreal Engine, Blender, Maya, almost anything you can think of, as well as like professional development, being a manager, managing technical teams, taxes, tax software. It's a really great resource. So if you do have a Boise Public Library card specifically, I know they have a free account. So you can go onto their website and look for the Lynda stuff, and it's all free and it's awesome. And you don't even need to take this course because there's like probably 20, or actually there's probably even more than that now, iOS courses on there. And it's awesome. So yeah. You don't have to come to class anymore. Just go on Lynda. All right, so jumping back a little bit, to give you a brief history on iOS, just so you understand kind of where some of these things come from. In the past, Objective-C was our language of choice. It's what I used to teach. I've been teaching it, or I first started on 2003, wearing my WWDC shirt, 2004, so you know I'm legit. But Objective-C was my, the love of my life, and then it broke up with me, and Swift came along and said, "I'm your new, your new love." And so I said, "Okay, let's see if we can make this thing work." So as much as I love Objective-C, rest in peace. We no longer really use it. It's still around. You can still program in it, but Apple has moved all the APIs, all of their SDKs, everything pretty much is Swift. So as I said, rest in peace. It was a great language, but it was built off the C language. It was a very thin superset. It basically added classes to C way before C++, which is also known as C with classes. But anyway, it was really cool. It was kind of a mix between C and Smalltalk, if you guys had that in your comparative languages class or whatever programming language, whatever the class is called here. I don't know. But yeah, anything you could do in C, you could do in Objective-C. I once wrote an application that had a server ping feature, and I got the code to do pinging of servers just via a C library. There was a C library online, open source. I just plugged it into my Objective-C. I kind of connected the functions and everything, and it just worked. You can do some similar things with Swift because you can still use Objective-C intermingled with Swift. Not necessarily in the same file, but you can have a file in either Objective-C or even C++, and use that code in your Swift or iOS application. So if there's an application like computer vision or machine learning that's written in C, C++, you can actually use it. So this is kind of why I mentioned this, but it is history, so we'll talk about it. Cocoa Touch is the actual SDK. This is what adds all of the collections, arrays, dictionaries, string types, data types would be under data. String type would be under data type. Functionality and views. Those are all part of the Cocoa Touch SDK. And then within that SDK, there are several modules that we include. We'll go over that in a second. But that is Cocoa Touch, which goes on top of Objective-C or Swift. Now you might see these prefixes, NS or UI. You'll see UI more often now in iOS development. You won't see NS anymore unless you're looking at some old code. And if you are using third-party libraries, which I do allow in this class, if you have a library that does some fancy UI or geofencing, whatever, and you just don't have to write that yourself, it might be written in Objective-C, and you might see this NS prefix. So NS stands for next step. Does anybody know who next step was? It's past tense. Nobody.
Was next like company?
Yes. So next is the company, and then next step was basically their version of the SDK, their programming, their libraries for their operating system. And they had the Next computer. That was Steve Jobs' company when he left Apple or got fired, however you want to. He started his own computer company. They did okay, and then eventually Apple decided to buy Next, and I like to refer to it as when Next acquired Apple, because Steve Jobs came back and he basically saved the company from bankruptcy in the late 90s, if you guys remember that. Does anybody remember the late 90s? No. Okay. Well, some of you do, but they're like, yeah, I was born then. That was just a joke. Anyway, yeah, it's all kind of history, but that's where the NS comes from. I'll show you where that comes in. But we have like NS string, and these classes have the prefix. Anything that's UI related is UI. So UI something, we'll talk about what those are in a second. But these are only, actually I haven't done any Mac development in a while. I don't know if this carries over to Mac development. If anybody either on the chat, I know there's actually a couple class people on there right now, but if anybody wants to see if UI is used on Mac development, I'm not sure. It was introduced in iOS, but yeah, now everything that has to do with the UI, like UI color and that sort of thing, is prefixed with the UI prefix. All right. Apple was working on removing all the NS prefixes from their classes and just naming them regular classes. So we'll see what these are in a second. There are two modules, we'll call them, back that you'll see very often in iOS development. We have Foundation, which is all the low-level either data structures, collections, or data types. So the core collections, just to name a few, are NS array, NS dictionary. The data structures, NS string, NS URL. So if you want to construct a URL, have a host, have parameters, have all sorts of things that go along with NS or NS URL. All that functionality is contained in those classes. And then functionality is NS Notification Center or Operation Queue. Notification Center is where we do our broadcast design pattern. If you don't know what that is, don't worry, we'll talk about it. And then multi-threading is sometimes done using an operation queue. It's just one way of doing multi-threading on iOS. But that's functionality versus data structures and collections. All right, so here's some of the more relevant stuff. Now we're kind of moving into the present. UIKit. So there was Foundation and then UIKit. UIKit is all of the iOS-specific UI elements. So UI button, UI view, UI color, as I mentioned before, UI label, if you just want to put some words up on the screen. That's a label. All right, so here are some of the other examples that we used to have in Objective-C: NS string, NS array, NS dictionary, NS data. So data was just binary data. If you had either an image, it could be a data object, or it could be any binary data. Mostly when I worked with it, it's like JPEG data or PNG data or something like that. So as of Swift, actually I think they started this right away in Swift, but NS data was NS data up until Swift 3, and then one day they changed it on me, and I was like, okay, none of my apps were compiling, and so now everything is pretty stable. So as of Swift 5, we've gotten rid of NS on everything, and now it's just string, it's just array, it's just dictionary, and it's just data. If you don't know what a dictionary is, it's just a hash map or a map or an associative array, or all these different things have the same name, but they're slightly different. But anyway, we'll talk about all of this. All right, so some UI classes besides the ones we already mentioned. UI image is the actual image data, and then image view is the view of the image that gets displayed to the screen. So basically what you do is you load in an image, a UI image, and then you give that UI image to an image view, and that UI image view lives in, on the next line, a UI view. So the UI view is actually what's on the screen, and that's controlled by a UI view controller. Okay. We also have a subview of view, and by the way, everything that's on the screen is a subclass of UI view. So UI table view is a UI view. So all the functionality we get in view, we get in table view. And then UI table view controller controls all of the data that gets shown in the table view. So a table view, if you're not familiar, you can just think about it as a fancy, or maybe less than fancy, Excel spreadsheet. So you got rows, you can sometimes have columns, and that's the thing that you scroll through on iOS. So as you're scrolling through things, it's probably a table view controlled on the back end by a table view controller to basically say how many rows there are, what gets displayed in each row, etc. And we'll cover all this, but just give you an idea what all this stuff is. And then finally, UI color, which is blue, black, RGB value, hexadecimal, yeah, all that fun stuff. All right, so again, we're going to kind of go down into the bowels of Swift and Objective-C, and then we'll come right back up in a second. But NSString is a constant. So if you set a string literal, meaning everything between two, the air quotes here that I'm doing, that is a string literal. And then once you set that to a variable of NSString type, then you could no longer change it. And if you wanted a string that you could change, we call that mutability, and we have NSMutable string. So again, if you wanted to create a variable, you'd have to declare it as NSMutable string or as string, and if you messed up, you'd have to either add mutable between those letters, and it was kind of obnoxious, but there was a really good reason for it. We'll get to that in a second. Here's the other classes and their mutable equivalents. But in Swift, we have the same class name for each class. So string, a mutable string is still a string, an array, a mutable array is still an array, dictionary and data, just as some examples. However, you might notice that the first keyword, let and var, is different. So an immutable type, or you can think about it as a constant, is let. So you would declare it as let and then the variable name if you never wanted to change that variable. If you wanted to make the variable variable, and I'm using those interchangeably, but if you wanted to make a variable that changes, hence a variable, then you would just use var. Very similar to JavaScript if you're familiar with that language. So a let, I often say a let variable, but that's what I mean. It's not actually a variable. It's just, we always call these things variables, right? All right, so I'll skip over this really quickly, but here are some of the capabilities of the different iPhone versions. I haven't updated this in a little bit, but if you want to know what the screen size is, like 1024, 768, or I forget what the newer phones are, they're a lot bigger. There's some links in there. You can investigate that. Some of the device capabilities that we'll talk about in this course, GPS, geofencing. We'll use the accelerometer, which basically tells the orientation of the phone, whether it's up like this, sideways, or tossing it up in the air. Actually, that accelerometer will tell me the G-force on that phone. And there used to be an app where you literally throw your phone up and see how long it would stay in the air. And hopefully you caught it on the way down. But using the accelerometer, it would tell you how long it was up in the air. And I've seen other applications where people have taken them on roller coasters and used them as like a scientific device and see what's the max G-force that they experience and in what direction. So there's a lot of really cool things you can do with the accelerometer. Maps, obviously you know what those are, but you can use them embedded within your own application. So you can do your own directions. You can say, here's a location. I did an app for a company here in Boise that had several offices in Boise and actually other states, and so I showed a map and pins of all their offices, and you tap on the pin. And it was pretty cool, but it was embedded in the application itself. I didn't have to send them out. So some of the other capabilities, we'll talk about some of these, not all of them. Like we won't talk about Bluetooth, but do know that it's there and you can communicate with a Raspberry Pi or an Arduino or something like that. So really cool stuff that you can do with your phone. Basically, it's a supercomputer in your pocket, right? Just a quick list of all the features and other capabilities that come with the different versions of iOS. So right now, we're coming out, or we as an Apple, is coming out with iOS 13. So it's been quite a journey for me because I started developing for iPhone in iPhone OS 2. So you can see that it used to be called iPhone OS up until iOS 4, and they switched the name and they had to pay somebody for those rights because apparently there was already an iOS somewhere else. Anyway, you can see that multitasking wasn't added until iOS 4. So we had 4 versions of iPhone OS come out before multitasking. And Android, everybody on Android is like, well, we've had multitasking pretty much since day one. But yeah, so you can kind of see how these things progress. So up to 12. I didn't update it for 13, but all right, Swift, real quick. Swift is just it's a general purpose programming language. Actually, I was looking up the definition of C++ for some reason today, and it actually almost has the same exact definition. C++ is a general purpose programming language. Swift is the same. It's not just for iOS. We talked about that the other class. And here's an example. There's a Node.js-like web server in Swift. It's called Perfect. I have never used it, but it's been out for quite a while. And if you really love Swift, then you can do almost everything in Swift, including a back-end web server. So anyway, just wanted to point that out. All right, let's get to the good stuff. We got a couple more, got plenty of time. But yeah, this is not, none of your assignments are going to be due. So next week we'll have you do an actual application. So just sit back, enjoy, and we'll talk about Swift. All right, so Xcode, I'm going to click on that first option, which was Playgrounds. So Playgrounds is not a full iOS application or Mac application or console application. It's just a nice way that we can play with Swift. And they give you a couple of templates here to play with. There's a blank one, which is pretty obvious. You can have a game, and that will include SpriteKit with a whole bunch of other kind of boilerplate code that you can play around with and modify and just see how it works. There is a map, which allows you to embed a map within your application. And there's a single view. Right now, we're just going to do a blank application. We'll get to the single view in a second. I'm just going to dump this on my desktop. It's fine. All right, hopefully you can see that. Maybe make it a little bit bigger. Maybe up to 20. Let's do... I gotta highlight all of them. Won't let me do just... Okay, we'll do this for right now. We don't have a whole lot of code to show you. When we get into more code, it might be a little bit too big. Okay, so what this is doing initially is importing the UIKit so that we can use UI elements. However, I'm going to switch this down to Foundation. And you can see as you type, this comes up. And we also have AV Foundation, which is audio video, and then Core Foundation, which is even lower than Foundation. But I've never actually used that. They have really low-level string classes and that sort of thing. That's all in Core Foundation. But if you're doing iOS applications, you probably never need it. But that's what that is. If we did want to include other libraries, you can do import, and then like SpriteKit is there. There's a whole bunch of other ones in there. Playground support we might need just for playgrounds. Okay, so that adds additional functionality, just like it would with Java, by importing packages. And here's our first assignment for this variable. Now this is a variable, so it is var, the name of the variable. Do not ever do this with your variable names. I don't know what str is. Is that a string? Is it a stir? Is it a... Yeah, I can guess what it is, but let's just say playground string. Okay, you can end your variable names with the type. Sometimes helps. And you can see that this is an implicit decoration, meaning that nowhere in the decoration of this assignment do you see the keyword string or the class name string, right? If this was Java or some other C++-like language, or C language, I should say, it would be something like, oops, autocomplete, string, and then let's just do play, if I can type, there we go, something like that. right? You might be used to that kind of declaration. But this is Swift. So it's very similar to JavaScript with a bunch of differences. We can also create a let, and this will be a playground constant string. Going to be very wordy here, verbose. Cannot change. Okay, and the other thing you can notice is at the end of my lines, I do not have a semicolon. However, I do believe we can put one in there if you want. I think that's fine. I'll go ahead and save this. I don't see any compile errors. It actually runs. Actually, no, sorry. Let's go down to the bottom left-hand corner, this play button, and hit play. And I will also tap and hold, and we'll run this automatically so I don't have to keep hitting that button. So semicolons are acceptable, though certainly not needed, and that's not what we do, so don't put semicolons in if you want to look like you're a legit Swift developer. And you're probably wondering in that gutter on the right-hand side what that stuff is. That is the return value for that declaration, or that for that line of code. So yes, it is saying hello playground, and that's what that's returning, but that's actually the return statement for the assignment. So if you guys know anything about chained assignments or return values or operators, yeah, this actually pops up a return value of that string. But this is just what this is showing is hello playground, and then I'm doing this assignment, and it's just showing me the value of that assignment. So if I try to do let, and let's say some number equals 1, and then I try to do some number equals 2, and I save that and wait about a second or two, it should give me an error. So down here in the bottom it says change let to var to make it mutable. Okay, so a lot of people I asked, you know, do you know what mutability is? Do you know what mutable is? And they don't. So that's, if you ever see this error and you're like, I don't know what that means, now you know. So basically what it's saying is that this let needs to be changed to a var in order to change this variable. Oops. And sometimes with the autocomplete, it puts in more than I want. Okay, so go ahead and save that. That error should go away. Yep. Okay, so you can see the assignment, the output, basically the result of that line of code is 1. And then you would see that, yes, on line 9, it's 2. No big deal, right? But again, nowhere do you see string. Nowhere do you see number. Yes, go ahead.
How come the assignments of playground string and playground constant string are no longer shown on the right? Did you only run those 2 lines?
That's a good question. So yeah, why is this? Let me make this a little bit smaller. I think it's.
You can do the command minus so that text is a little bit smaller.
Yes, thank you. Play with that a little bit better. Let's see. Oh, maybe I'm running this automatically. There we go. So yeah, you can. The nice thing about playgrounds is once you set it back to manual run, you can run it only a few lines at a time. So I can just run it up to line 2. And you see the lines that are in blue or have not been run yet. So I can run it up to line 5. Now line 5 is, it should have been executed. I do not know why it stopped producing that. That's a good question. Yeah, it just disappeared on me, didn't it? Okay, not really sure why it did that. However, if you wanted to, you can print out. It's a function, print playground. Oops, not playground. Gotta be careful with that autocomplete there. Save it and run it all over again, and there we go. All right, so line 7 has executed. Line 8 and 9 have not, so you can just see that the printout of line 7. Yeah, again, I don't know why this is not working. But what I was going to mention is these are implicit declarations of these variables. So the compiler knows that these are strings because it's fairly obvious, you know, the double quotation marks and then the number here. This is actually of type int. If I go ahead and play this and I hover over it, sometimes this works, sometimes it doesn't. It works in the full version of Xcode, but Playground sometimes is a little finicky, as you can see, like doesn't or it doesn't print out that stuff. But these are actually integers. Okay, and I know that because if I said, instead of some number, I said some double, and this double was 2.0. Let me make this a var. Actually, everything, let me hit escape to get rid of that. Everything by default should be, if you can help it, be a let variable. I hate calling them variables, but you understand what I'm saying. Let, because it becomes immutable and it's actually a little bit faster in code. There's a lot of reasons for that that we won't get into today, but by default, make it let, and then if you did want to do some number, oh, by the way, if you hit escape on that, you can see in the autocomplete, it's int some number, so that's one reason I know it's an int. But if I try to reassign this to, let's say, 2, and I ran this, I get an error. And I can look up this error. Sometimes it pops up inline, but I'm not sure why it's not doing it today. Yeah, let's see. It was literally working before class, but sometimes I'll get a error. Let me see if I can run this. Let me do auto run. Oh, okay. I think it's... I'm just trying to get this error message to pop up, and for some reason it's coming down here instead. It's probably how I set this up, but anyway, sometimes you'll get an error message that's in line here, and it will say that you can't change it, and then you're actually able to click a button and fix it automatically by making this a var. Anyway, it probably has something to do with why that's not working as well. Okay, so anyway, real quick, we have a variable. We tried to change it. It didn't let us when we said let. We changed it to a variable to make it mutable. But the other thing I wanted to do is when I said some, now that we can change it, we can do some double multiplied by, let's say, another integer. Okay, and we're going to get another error here that says cannot assign value of type double to int. Okay, again, nowhere do we see that these are of type double or int. I just know it because of the way that I've declared it. Xcode, the compiler, will always kind of default it to whatever it can assume. And an integer is a lot better than assigning a variable as a double, because the double doesn't have the precision that an integer does, right? It's one reason why we never compare double floating values, right? Because somewhere down in the 9 digits long, depends on what architecture you're on, it's like 0.0000003, right? And so it's not exactly 1. So if we want that, we can explicitly type it as a double. Now this works because on line 11 we're multiplying a double by a double by an integer, but then we're taking that and assigning it to the double. It wasn't allowing us because of this double. This product of this multiplication was of type double. We were trying to assign it to an int. So either make everything a double, or you can typecast it as an integer. And that works fine as well. What happens though is instead of, let's say this was 2.5, you can see the value of that is 4, because 2 times 2 is 4, obviously. Actually, I shouldn't have done an even number. Let's do 2.2. Bad example. It's still 4, because 2.2 times 4, or excuse me, 2.2 times 2 is 4.4. However, because we're typecasting in an integer, as you guys probably know, it just truncates the decimal points. So we can. It depends on how much precision we need in our numbers, but essentially that's going to be the error messages that you will get. All right, and then finally, got one more thing for you, is string types. So again, let's just start off with this, and we'll put a name, and this person's name is Mike. No relation to the 3 other people in here. Also named Mike. And I know one's on the chat, so anyway. Yeah, so we have this name, same thing, I can't change it. I can't do anything with it, but what I can do is, just like every string class that you're familiar with, I have a bunch of operations on that class or that instance that I can operate on. So I can get the count of how many digits, or excuse me, how many digits, characters are in that string. I can append another string. I can do a whole bunch of other things, end index. I can search on it. I can find substrings within it. I have basically all this functionality. So quite a bit of stuff on the string library. It's not all in the string. It might be a higher class that it inherits from, but there's a whole bunch of stuff in there split. But what you might not notice or realize at first is I have the same thing with doubles and integers. So these are not basic types in Swift. Java, they are, right? Java, if we have an integer, it's just a 1, it's just a 10, it's just 100. We can't actually do any operations on that variable. We have to pass it into some other function or some math library or anything like that. In Swift, doubles, floats, integers, booleans, they're all classes. Actually, they're technically structs, but you can think about them as classes. We have operations, we have instance variables of them, we have methods that we can operate on them. So doubles don't actually have too much in here, but for instance, we can get a distance to another double, which is usually located in a math library. We can ask if it's finite or infinite. If it's less than this, it'll return a Boolean value. So we do have some operations that we can operate on this type double. So that's another thing to know. With strings, as I said, we have the same thing, but let's say you want a bunch of strings. So we can say let string array equal, and then in brackets, probably like you're familiar. I'm just going to make some stuff up. Oops, double quotes. Sarah with an H. Sarah without an H. All right, no semicolon. And now we have an array of strings, but we can't do this. I don't think. There we go, as I say. Maybe in Swift 5, but no, we can't do that in Swift 5 either. So we can't mix types within our arrays, just like most languages. However, in Objective-C, we actually could, because everything inherited from the object. Everything was an object. Kind of like in Java, but strings and integers, they were all objects. So we could actually mix and match stuff in Objective-C. Can't do it in Swift, though. So anyway, let me just do one more thing, and I'll let you go. What I'm going to do is I'm going to say current string. So this is a for loop. So current string in string array, brackets, and I'm simply just going to print out whatever current string is. And there we go. So it loops through all the every element within the string array that we created here, and just printed them out as we went. This is what we call a fast iteration loop, or a for each loop in other languages. So it just loops through this guy, stores the current value in here, and then we can work with it in our for loop. We do have range for loops, but I'll show you that in another day. So thank you guys for coming out. I do appreciate you spending your evenings with me, and I'll see you on Tuesday. And watch for the email, and that should explain all, or it should answer all your other questions.